Hello guys, I hope you are doing extremely well. Today I will discuss the problem which is the kth largest element in an array. So what is the problem? Problem is that we have to given a array and find out the kth maximum element. So what is the kth maximum element in that particular array? Kth means second maximum element. So first maximum in that particular array is the 6 and second maximum is the 5. So our answer is a 5. Okay. Now we will again take another example. Which one is the 1, 2, 3, and 4? K equal to 3. Third maximum element. Okay, so now let's again we will check. This is the first maximum, which is the 4. This is the second maximum. Okay, this is the third maximum. So our answer is the this. Yeah, observation is clear. Now, how to approach this problem? Okay, first of all, brute force comes in your mind. If I sort that particular array, which one is a 1, 2, 3, 4, 5, 6. If I sort that particular array and if I return, check. This is the size of the array. Size of the array is the 6. There is 6 element in the present in that particular array. Indexing is 0 is 0, 1, 2, 3, 4, 5. There is, can you observe one thing here? 0, 1, 2, 3, 4, 5. If I subtract size, how many elements in that particular array? 6 minus k equal to 2. Return 4. Fourth element, because the indexing in the array is starting from 0. So fourth element in that particular array is that here. Yeah, now let's talk about this example. Size of the array is 4. Okay, k equal to 3. Find out 1. 0 indexing 1, 2, 3. So 1 here and we will simply return here. This is here. So yeah, if I return, so what we are finding the conclusion of that particular array is that if I return nums of n minus k, this is my final answer. Observation is clear. Are you getting my point? Simple. But okay, okay. Problem is you have solved this problem in only 2 or 3 lines. Okay, once let's uh, taken, this is the first example and this is the another example. Here this is talk about the k equal to 4, fourth largest element. So first one is the 6 and second one is the 5 and third one is also 5 and fourth one is the 4. Okay, because here 5 is present 2 times, so we are considering as a one particular element. Okay, don't skip that if the element is present 2 times, because the index somewhere index is index of that repeating element um, take. So don't skip this. Yeah, so if I sort numsrod begin, sorry, comma nums dot end, and simply return nums of size. Now let's find out the size. Int n equal to nums dot size, simply written n minus k. Now let's see this will work or not. This is working. Yeah, as simple as that. So now let's talk about the time and space complexity. Okay, so first of all, we are sorting that particular array. This is this one. So sorting function, which is the predefined function, it takes the time complexity of big O of n log n. N log n, okay. Space complexity, big O of 1, constant space. But time complexity is not a good, because here we are talk about the heap data structure. Here we are using the heap data structure. How? Because we have two types of heaps. First one is the min heap and second is the max heap. In a max heap, the maximum element present at the top. If this is the max heap, so maximum element is here. If I talk about minimum min heap, so max element present here, min at the top. In a min heap, min at top and max heap, max at the top. So how to approach? Okay, but in a min heap or max heap, element will be arranged in the sorted order. If I take a min heap here, okay, now let's, if I put every element in the min heap, then I already talk about the, if we are using the min heap any key, it means that max element present at the bottom. Okay, okay, okay. So 6 will here, then 5, then 4, okay, then 3, okay, then 4, okay, then 1. This is it. So can you observe one thing that over here, if I check a condition, if pq dot size, pq dot size is greater than k, because k equal to 2. Whenever the element which is the size of the k greater than, the indexing of that element is the greater than size of the k, then simply pop. After putting these element, whenever 4 come, and we will check the size of the queue, sorry, yeah, size of the priority queue is greater than, yeah, simply pop out, do nothing. Again 3 will come. Now we will again check the size of the priority queue is greater than, whenever I put the 3 in that inside the priority queue. Yeah, this is greater. Simply pop. Now again check 2 putting in the priority queue, and then we will check the size of the priority queue is greater than k or not. Yeah, this is greater than. Simply pop. Again we will check for 1, and this will also take a size of the priority queue is greater than k, so simply return. So yeah, so this is the our observation using priority queue. Okay, so now let's write down the code, and then we will dry run again. Okay, if I write down priority queue int comma, first of all check greater. Okay, so this is the priority queue, min heap. Okay, if you are write down the max heap, so simply priority queue int pq. Okay, so max heap is the little bit easy to write down. This is little bit difficult. Okay, so now we will iterate over here for int I equal to 0, I is less than nums dot size comma I plus. Okay, pq dot push. Now we will push every element. Pq dot push nums of I. Okay, now we will put every element in that particular heap. Okay, yeah, pq dot push nums of I. Okay, now we will push the 6 here. Now we will check if pq dot size is greater than k. If this condition is true, simply pq dot pop. At the end, simply return the pq dot top. Okay, okay. So now let's dry run. It says that pq dot puts nums of I. Now we will check that condition. Pq dot size is greater than k or not. No, the pq dot size of the pq is the one. Again, for loop again iterate and push second element in the order of like that. Again we will put 5. Okay, now we will push a 5 and again we will check that pq dot size is greater than k or not. K equal to 2. No, size is not a greater than. Yeah, this is equal to k. Size of the pq is equal to k but not a greater than. We will terminate the condition whenever the size of the pq is greater than k. Again push. Now we will push 4. Yeah, size of the pq is 3, k equal to 2. It means that size reach, whenever size reach over the k, then what we will do here, we will simply pop that element. Okay, again iterate over here, push 3, size is again greater than k, again pop. Now again push 2, size again greater than k, again pop. 1, again 1 2 3, 3 is greater than 2, yeah, pop. After iterating all the array using for loop, now we will iterate the array completely, iterate the array. Then we will return the pq dot top. What is the top element? Top element is the 5. Yeah, this is our answer. Are you getting my point? So problem is very simple. You know, although this is marked as a medium, but this is not like a medium. If you are a little bit better idea of the priority queue, min heap or max heap, although you can use the max heap, and if you are using max heap then you have to iterate the two loops, which one is the for and another one is the also another loop. Then we will put every element in any integer, variable. Then you can simply return. There is a multiple approaches to solve this problem, but this is the most optimal. So now let's talk about the mm, time and space complexity. So the time complexity of that particular array, sorry, that particular approach is the n log k. Okay, n log k, because somewhere it is take n number of iteration, and again it is check that every iteration in a pq dot size. So it is somewhere around the n log k, but size means, sorry, space complexity is the That particular approach is the BIGO of K. At least number of K element we will put in that particular, you know, priority queue. So it takes a okay. Now let's find. This is the fine. Okay, so this is it from my side, and this is the time complexity. This is the space complexity. This is the optimal approach, and yeah. So this is it. So thank you so much for watching this video. So I will see you next time.